Welcome, everyone, to this afternoon's CUR conversation. I am Luke Zimmer. I am here representing CUR. If you have any technical questions, feel free to direct message me and let me know. If you can, please keep your line muted while our presenters are speaking. We are recording today's session, so just to make sure to reduce any background noise and stuff like that. However, we do encourage you all to jump on the line if you have any questions, or add your questions to the chat if you have any for the presenters today. And with that, I will go ahead and hand it off to our team to introduce themselves. Let's see, Leslie, would you like to go first?
Sure, my name is Leslie Chow. I'm an associate professor at Lehigh University in the Departments of Material Science and Engineering and Bioengineering.
Hi, everybody. This is Eda Yıldırım. I'm associate professor in Bioengineering Department, University of Toledo.
And I just want to jump in. I'm the engineering CUR counselor, one of them, and just wanted to say that Eda is our 2021 Undergraduate Research Mentor Award winner, and Leslie is our Early Career Undergraduate Research Mentoring Award winner, and they're just going to be sharing their thoughts today. Each one of them has a short presentation prepared for us, and then we'll have some Q&A at the end. And so with that, I think we can let Eda start her presentation.
Sure. So is it good? So working well? Everybody can see the screen? Okay, perfect. First of all, thank you for inviting me on this conversation, and I hope I can share my experience with mentoring undergraduate students. So why we need to mentor undergrad students? So I just would like to go with the data, because we are all scientists, and I think I believe it's straightforward. So doctorates awardees by US colleges and universities keep increasing. There's a slight decrease in 2022. That's because they think it's about COVID. We will see the trend in near future. However, there is a good trend that it's increasing over the years, especially for the science and engineering field. And we would like to feed the pipeline. And one of the main reason, at least for me, is keeping the students in the research, engaging them early enough so that they can do their PhD and then become a scientist and hopefully get their PhD degree, and then incorporate more effort into research. And first thing first, let me introduce what I have been doing. I'm an associate professor, and I have been working in musculoskeletal tissue regeneration, particularly in the area of regenerative rehabilitation. So we are working with mechanical loading and applying to tissue, ex vivo tissue, in vitro tissues, and then see how cells are react. So these are very exciting for undergraduate students. And every time, no matter if I'm teaching freshman classes or sophomore, junior, or senior level, in every class, in the very first lecture, I introduce my research topic to the students, because I think throughout the semester they are very much aware of what is the topic is all about and the lectures all about, but they don't know us. They don't know us as a researcher. They see us as a like high school teacher that comes to teach. However, we have a completely different life after teaching the lectures, and we have an ongoing research. So I just would like to emphasize that part of our duties in the college, and then telling them that this is the research area that I'm working on, and that helps me to recruit undergraduate researchers. And because the area musculoskeletal tissue engineering is interesting enough for them, So that I'm fortunate enough that there are so many of them. They would like to, work under my mentorship in research. So recruitment of undergraduate students are important. As I said, I highly recommend everybody to talk about research in their class before they start their first lecture. And then I also encourage, after recruiting them, I encourage them to write undergraduate research proposal. That's important because, I have many of them would like to involve research, but only maybe 50% of them are serious enough. And it's helping me to weed out students who are not really interested in research, but only trying to add a line in their resume. Because although I love to accommodate as much as I can, but there's a limited space and resources in the lab. So that is helping me to identify if students are really interested in research and they know what they are doing. Of course, I help them to write the structure, their proposal, but this is one of the first steps that I apply when I'm recruiting the undergraduate researchers. Also, I motivate them in research in early years. Every year I accommodate at least one freshman student because I'm teaching freshman design, and that helps me to recruit freshman student. And if you recruit them early enough in early years, that you can really mentor them, and when they hit their junior year, they are as good as seriously PhD student, because they know all the protocols within the lab. They know your writing styles, they know how to read scientific articles, they know how to write scientific writings and everything. So mentoring them in motivating them in research in early years is very important. And if you do a good job, I think, other undergraduate students are telling, their friends, hey, look, I involve research and I have done this experiment, I use this equipment, and I have just really interesting results. And they start to advocate for research. You don't need to do much. Once you engage with other undergraduate students and then be productive in the lab. So those are important things that I follow recruit undergraduate researchers. Yet, as I said before, we need to be selective because ultimately when they involve research in the lab, I'm not always in the lab because I'm teaching, writing proposals and other services in the department. So therefore, graduate students are mostly mentoring them in one-on-one mentoring during the experimentation, or undergraduate students are shadowing them. So we need to consider our graduate students' time. So that's very important because the more distraction you create for grad student, your research productivity drop. So therefore, we need to be selective when we are picking undergraduate researchers based on your time and graduate students' time. Also, the other thing is resources. Now, things are really expensive, especially in tissue engineering area. Chemicals, reagents are crazy expensive, and undergraduate student researchers can really deplete them. So you need to tell them, and then teach them being mindful when they are using the chemicals, and follow the protocols and then concentrations, this and that. So we need to consider with resources when we are deciding how many undergraduate researchers we would like to recruit. The other thing is the lab space. Especially after COVID, so many of us have a restriction number of people accommodating in the lab. So therefore, it's very important not to cramp so many people in the lab, especially after COVID era. Even before COVID, it's not a good idea. We had several issues with prior to COVID. So those are the couple of considerations we need to consider when it comes to recruiting undergraduate researchers. So when it comes to mentoring tips, what I can suggest is we need to give them clear guidance about the expectations. And when we give them guidance, also we need to tell them how to achieve those expectations, because these are, these students are taking heavy course loads. So research is something they would like to involve, but we don't want to scare them. We don't want to overwhelm them, and then they just say, oh, wait a second, I'm not sure, I want to do research. So when we lay out the expectation, it can be easily overwhelm them. So I start to tell them, look, we would like to do this, but this is how we are going to achieve them. So I always ask them, what is your purpose when you would like to involve research? Some of them would like to apply national scholarship, so they would like to have a publication. Some of them would like to go grad schools, so they would like to have publications and meaningful research experience. So, and I ask them, okay, if you want to have a publications, then look, these are the publications we have published so far. You see how much data is involving in it. Then if you would like to be a first author, you need to do the majority of the work. And then this means that you need to spend 1 or 2 years at least in and out within the lab, so that you can generate enough data for publication. And then step by step guiding them. Look, let's go backwards from your timeline and then decide when you need to start writing. And then based on that, let's decide when you start your experiment. And then slowly, easing into how they need to achieve all this expectation. And I always couple undergraduate researchers with PhD students, because they are the one primarily doing experiments, and undergraduate students start shadowing PhD students, and then I let them do their own experiment. So that's also important. And I also provide them meaningful research projects. I respect their time, and I expect them to respect our time as well. Although, any experience is good enough, but if they would like to have a publication, they need to have their own project. So literally, I tell them, look, I think you can do it. It's an ambitious project, but I think you will be able to do it. And then with helping them a little bit more than grad students, they are creating a fabulous job, and they publish in a first author in a high-ranked journal. So, but that is only possible, that's only possible providing a meaningful, their own research projects. Otherwise, they cannot be a first author. The other thing we need to do is, I think we need to mentor them how to find scientific articles. So they sometimes Google, which is fine, but I always suggest them to use EndNote, because it's a great search engine for scientific articles, and then they can store the PDF file. So within the one file, EndNote file, they can search, store, and then share with me. So when we write the manuscript, it will be easier for everybody to find the things and then cite them. So, and I ask them to read scientific articles, teaching them how to find it, read them, and then I ask them to summarize at least 20 of them initially, until they understand what they are reading. After that, they will much more comfortable reading and understanding the data. Having said that, I always check their progress every 2 weeks, because that's important for them, that I'm caring what they are doing. It's not like assigning a task and not follow up. So I care what they do. And then if they see that I'm following up, they are also getting really serious and then, completing the task on time. And after, involving lab in around 6 months period, I let them do their own experiments solo. And I ask my grad student not to help them, and then let's run their experiments. Most of them, they cannot generate, reliable data, but at least that running experiment by themselves is helping them to understand what kind of mistakes they can do and then fixing them. Because shadowing, it's okay, they learn, but they cannot understand the, the small mistake that may lead to a bigger one until they do the experiment itself. I also explained that, when failure happens, in the experiments, they discourage. And I tell them, this is the research, this is the nature of the research, we are learning from our failures. So next time you need to be careful. So we need to encourage them to be more resilient when it comes to failure. And that's important part of it, because I would like them to engage in research and then thrive with it. So any failure can be really, especially with earlier freshman students, they easily discourage. So we need to build resilience in them. And that's it. So I didn't want to put so much. However, I need to mention that, I have many publications with undergraduate student as a first author, and I'm very proud of them. They usually follow, they are with me around 3 years or so, but at the end of it, they are rewarded as with a publication, and that's important for them. And I'm very proud of all of them. And they are now, some of them are doing grad students, some of them went to medical school. So it's I'm really happy what I'm doing, and then hopefully I can continue mentoring them. Thank you so much.
Thank you. Really appreciate that. I think one of the most inspiring things from your awards documents were just how many undergraduate students you've had, over 30, I think, and many of them have published as first authors or co-authors, so really great. I think we'll save question and answers till the end and let Leslie talk. Leslie also has provided substantive research opportunities for a really diverse group of students, over 30 undergraduate researchers since starting at Lehigh in 2015. So I'll let her now talk about her work and how she, what her take is on mentoring undergraduate students.
Sure. So I really appreciated that. And it reminds me, especially to hear from somebody who's been doing that longer. I think I really appreciated hearing your talk and your approach to it, and definitely took some notes to think about how to adapt for myself. So I'm going to tell you a little bit about what my lab does in the context of how undergraduate research is integrated. And so hopefully you'll be able to see, how those pieces fit together. And just like Ada said, it's really critical for them to have substantive projects. It's really critical for them to be involved and be part of the group, and be really fully integrated for them to be successful. And that's something that, there's trial and error as I started. We got to a good rhythm, and I'm really proud of where we've gotten to. So I did want to, in case anybody has no idea where Lehigh is, I thought I would give you a little bit of context. So this is our campus in the fall. It's a very beautiful campus. We're located equidistant between New York City and Philadelphia. So if you are ever interested in visiting, please feel free to let me know, and I'd be happy to show you around. But we're very close to those two cities, so that's really nice. I also wanted to start by saying one of the things that is really important to me, not just from the context, the students are talented, but they also have to be very kind. They have to be really good humans. And that's something that has been a big central part of the theme of how we want to work together. And so we came up with this ethos, which was adapted from a poster that Sammy Kata made. In our lab, we believe that science is real, love is love, Black Lives Matter, feminism is for everyone, immigrants are welcome, and of course, in our case, biomaterials are cool. So we're really guided by structure-property relationships. So we're a bunch of engineers from different disciplines in engineering, and we all think about this in a very similar way. So if we think about the structure-property relationships in materials, if you've ever taken an introductory materials course, you would have seen some sort of paradigm like this where the structure and processing of a material affects its properties and then its performance. So this same paradigm can be applied to native tissues, where the architecture, the remodeling, and the properties influence the biological function. So this is what's really driving us. This is the way we think in our lab. And we're really thinking about how we know tissue function is tightly linked to its biochemical and physical organization. Is there a way for us to design biomaterials to drive the reorganization or the regeneration of that tissue back to what its native tissue really looks like, to really get that function? And so, just as the previous speaker said, we're very interested in musculoskeletal tissues. And they give a great example. If you think about from the nanoscale to the macro scale, how you have collagen fibers and hydroxyapatite crystals, the nanoscale, and then you have blood vessels that are providing nutrients and oxygen to those cells and to the tissue, up to the macro scale, where you have this really remarkable lightweight material that's load bearing, yet it's made out of materials that are terrible for load bearing, right? From an engineering perspective, it doesn't make any sense why bone is made out of soft polymers and brittle ceramic materials. But nonetheless, the organization is really what drives that tissue function. And so the approach that we do in my lab is we're trying to design modular building blocks. So we want to be able to make biomaterials that have highly tunable biochemical and physical cues so that we can then construct something that will drive the formation of different tissues. So we start with this building block. It's very, very simple. So the primary building block that we're working with is we just take a commercially available biodegradable polymer, we attach a peptide, and then we come up with this very cleverly named peptide polymer conjugate. And then what's cool about this is you can change your peptide sequence, you could change your polymer, and now you've created this diverse library of different conjugates that you can use in different synthetic modes and fabrication techniques. So for example, a whole aspect of my group is using multi-printer head printing to be able to construct scaffolds that have multiple peptides presented on the surface. And we're also blending with polymers to create transparent membranes for wound healing and cornea applications that have these spatially organized properties as well. So what's nice about our conjugate technique is that it gives us this really diverse ability to make different types of materials. And so one thing I really want to emphasize is that we're working with this one molecule. So everybody in the group learns how to make that one molecule. Everybody learns how to synthesize it. And then each person can run with whatever direction they want to. So this makes it really nice to make undergraduate projects, because synthesis and things like that can be relatively straightforward. They can learn and make their own molecule, and then they can use the different types of fabrication techniques to construct something of interest, right? So we can make porous foams by particulate leaching. We can make, aligned columns. We can cast membranes. We can electrospin, or we can 3D print. And all of these allow us to make different types of biomaterials for different applications. And so what we ultimately do in the lab is make these constructs that allow us to control where the chemistries go. We can apply this for osteochondral techniques. We can make different scaffold architectures that are scalable for in vivo translation. And we can also just adapt our materials library to get the types of properties that we want, right? We know that the physical cues matter. We know the biochemical cues matter. We want to be able to adapt all of these different elements of our materials to be able to achieve the type of biomaterial appropriate for a given application. So what I want you to do is think about, and so we have this platform, everybody's working with the same molecule, yet if you look at all the different projects that exist in our group, these are all just undergraduates that either have just graduated or still in the lab or recently graduated. And so I just want to point to you to a couple of these examples where, you know, we have students that are from bioengineering that are working on cornea using the same molecule, just a different fabrication technique. We have students from chemical engineering, from material science and engineering, all these different disciplines, yet we all have this common goal. And what's nice is they can collaborate with each other as well. So they can, you know, build peer-to-peer mentoring, as well as they're all paired up. If you notice in the bottom corner, they're all also paired up with a graduate mentor. So we try to pair it up in a way that the undergraduate student is working on something that aligns with a graduate student's goals. So our motto is always win-win. So we always try to have where they're supporting each other. And then if an undergraduate student happens to be able to run even further with it, we let them run further with it. But we try to, you know, it's very difficult. If you think about the first lab, it's very daunting, right? To go into a lab and start to learn something new. And so we've done a really good job of setting up this, what we call a cascading mentorship model, where students come in, there's a lot of structure very early. They know, you know, what they need to, what sort of goals they need to achieve after the first semester, second semester, and so on. And then that helps us build in, you know, do you even like research? And it's okay if you don't, right? So that's another really big thing. It's okay if they start and they realize this is not at all what they want to do. And so what I like about this is that the best part, I think, of all of this job is the fact that you get to see them go on and give presentations at major conferences. So this is a bunch of my graduate students and mostly undergrad. They went on to present their work at a national conference in Orlando last fall. And then you also get to see them achieve things beyond that, right? So as Ada said, you know, we talk about what their goals are. We talk about what they want to achieve. And that really carves the path of what direction we take them towards, okay, well, what do you need on your CV? What would help you? What are things that you want to achieve? So things like, if you want to go to the medical device industry, I'll help you make those connections. And we try to tailor it so that you can talk about your research in a way that makes you stand out more in your interview. We have students that go to the NIH for their postdoc, which is really exciting. Many of them want to go on to MD PhDs or PhDs. So that's been really helpful. And we even have a student who has just gone completely rogue, and she's asked to do a startup company. So building on her bioengineering degree, she actually started a hair care company called FolliQ. And then the other thing that we do is we implement ways to have crossover. So one student is finishing up, we have another student coming in that will take over the project, and they still have their own plan for the project, but it's nice to have an overlap of at least a semester so that there can be training involved, both from the graduate student and the undergraduate student. And that also, from my experience, has taught the more senior undergraduate student to actually really understand their project more, because now they have to explain it to somebody else. So that has been really rewarding to be able to see that sort of behavior. So we've got 3 students that are coming in, a couple that we've already been in the lab. But it's nice to see that transition. So students picking up on projects that have been carried over from the previous student. And then ultimately, it's the big rewards of things like getting to see them publish. You know, so I haven't been as fortunate to have a student, an undergraduate student, publish as first author. That's now going to be my goal. So you've inspired me with that for sure. But what we have had are undergraduate students that are playing really instrumental roles in the publications that are coming out of our group. So this is just from 2021. I'm not even showing anything from before. These are just undergraduate students, and they're actually either doing a PhD, they're working in industry, right? All diverse like paths of career, but they all have played a really substantial role in building our group. And so I'm really indebted to them, and I'm very thankful for that. And so that's really the approach that we've been taking. And so I just wanted to highlight and show the faces of the people that are doing all the work, and really emphasize that, you know, people often think about undergraduate students as being almost a burden in the lab. And I've had the exact opposite experience. Many of the undergraduate students have actually almost ended up training. Actually, one of my undergrads will be training an incoming graduate student. I don't know how those dynamics are going to go, but that person is more skilled than the incoming graduate student. And so I have found that they, for recruiting and things like that, it's been really easy because the students that exist in my group, they want to have like-minded people of similar, like, hardworking ethic. So they go out and they recruit for me, which is really helpful. And so then we do like screening processes and interviews, and we vote about who we're going to take on. And so that also helps them feel a little bit more autonomy and ownership of their role in the group. And really, that they belong in the group. They're not just an undergraduate student. And so that has been really huge for us. So thank you.
Okay, I think so the idea here was to have some conversation and some questions about undergraduate research. And so we want to sort of open the floor to questions, but I had one that I wanted to ask first to sort of get things going, and then we can all have questions. But one sort of theme that I saw throughout both presentations was sort of students mentoring students. And I'm at a school that only has undergraduate students. So I could see setting up something where like the upperclassmen mentor underclassmen in research, but I was just curious what kind of advice and how do you teach students to mentor other students, I guess, and what advice and how do you set that up and how do you ensure it's successful? I think you're muted, Ida.
Okay, so you need to first mentor one of them, right? So let's say you teach one student already. I think next thing is, especially for undergraduate student, the most important thing is the scheduling them. You need to, because their schedules all over everywhere. It may not match with the student that you would like to mentor, and a mentee, they need to follow the same schedule. So I think that might be one challenge. However, the approach, I think, should be, you all can go to the lab together and then run first couple of experiments together, and then leave the relatively senior one to teach the younger student. And so, I mean, I don't know, without grad student, it's going to be challenging. I think it requires more your time. It's harder for undergraduate students to go solo. But, in certain cases, as Leslie mentioned, some undergraduate students become really advanced in the field that they teach upcoming grad students to learn how to do things. So if you are willing to put enough time to an senior undergraduate student, that student can teach younger one by spending quite amount of time in the lab. But that becomes boiling down, their schedule needs to really match. That was one of the challenging things, because one of my undergraduate students were running experiment, and I asked the other two helping that undergraduate student, senior undergraduate student, to help. They weren't able to do it because their class schedules are not aligning well. So but beside that, it is doable, but it may need more your mentorship.
Yeah, I would agree with that. I mean, I'm particularly now pretty heavily reliant on my graduate students, so I am very cautious about protecting their time. But when I first started in my first year, I didn't have graduate students. I don't know if so I have another requirement in my lab that I ask the students for at least a 2-semester commitment, because you don't really know if you don't like it, I think, if you haven't had a win. And I think it's really hard, as we all know with research, to have a win very early. So I ask for 2 semesters, and I try really hard to get that 2-semester to be a summer and a fall. And I've noticed that students that have a summer and a fall So I always find funding for them in some way. I encourage them to find their own funding. We have some opportunities on campus, but I also can get some support through some of my own funding. And that has been helpful. Students that start in the summer and then continue end up staying with me the rest of their time. And I think it's because some of those little things, like just being full-time in the lab during a summer, they just learn so much more than when they have to go switch their brain and go to class, or they can't come back to it after a few days. But then once they've spent a whole summer, fully immersed in the lab, understanding how long something takes them, they can start transitioning into that during the regular semester. And so in terms of like getting the mentorship, I think honestly, I don't have every student do that because not every student is ready or necessarily going to be a good mentor. And I don't mean that in a super negative way. I just mean, I think it's asking a lot for a senior student to mentor a junior student. And so the same thing with like protecting my grad students' time. They never have more than one undergrad that starts for the first time. Some of my undergrads, like I have one undergrad, Natalie, who like didn't need anybody. So we like have a mentor for her, but really it's more just like a, hey, can you order something for me kind of mentor. But those the pairing between a graduate student and undergrad has been more helpful. So I know when I started, I was in the lab all the time. And so unfortunately that's, you don't always have the time during the regular year, but the summer is the best time to do that.
Totally. Yeah. Without having graduate students, it's sort of like I have to take that role a little bit, but thinking forward, it might be cool to see if there's any possible mentorship opportunities. But yeah, you have to be really careful with it with the undergrads, especially with their time commitments are very small during the semester. Okay. Well, I wanted to open the floor to other questions or points of conversation.
So do you want us to ask or chat?
Oh, I think just asking. It's a small group.
Okay. So I noticed both of you emphasize publications with the undergraduates, which are very important. One of the things that, in the last year has been a little bit harder is things like posters. Can you comment on your experience in working with undergraduates in presenting their work as in posters or presentations as opposed to the publications? Are there any things you have to do to help get your undergrads ready for that activity?
I can go with that. Yes, publications, we help them to write, we have more time and, they don't need to present. So it's a little more comfortable for them to do. But poster and especially oral presentation can be really challenging for them, overwhelming, not challenging, but overwhelming. They get excited and stress out. However, what I do is, especially when they are ready to go to conference, they are in the senior level, senior year or so. So I'm teaching Tishinji class. So I invite those students to the classroom to present their work in one of the lecture. So, and, they are just, because it's their friends, they are easing out a little bit. And then I ask my students to ask question to the presenter. And then I ask myself, question to the presenter as if he is or she is in a conference. So, so that helps them to organize a little bit. And we have I have a folder in our drive, the template for presentations and posters. So I ask them to follow that template, and that template is not only organizing where they need to put the data, but how, the logic flow of logic, how they need to approach preparing the presentation. And I also put all the prior posters and presentation into that folder so they can see an example. So when it comes to outlining, you know, they feel comfortable. However, presenting the data, especially, you know, graphs and statistical analysis, those you know, relatively tougher things, they need practice. And then I let them practice in the lab, and then inviting to the tissue engineering class, they practice there as well. And then they are good to go after that.
Yeah, I do the same things. We have templates. I do have some, so they know ahead of time that they have to get things to me 2 weeks ahead of time, a draft, so that I know, you know, how long of a road it's going to be or short of a road. And so usually they do a draft, but I very strongly encourage that they have at least somebody else look at it, because I think just having students help each other is a better way to make them have to think through how they're going to lay out their poster or their presentation. So that's been pretty helpful. But the templates are key so that they see an example of what a good one looks like. That doesn't always mean that they're going to make that the first time, but I also do not just change things for them. So I make them sit there with me, and I will make an edit and I say why. And then I ask them, like, what else would they edit, and that sort of thing. So when we have posters and presentations, they have to do their practice of what it, like, we simulate exactly the same way. We simulate what it would be like. But we also will sit there and like just take notes about little suggestions and things like that. And that takes a little bit of the public pressure off. So we all hand them a card at the end. So instead of them feeling like people are criticizing them publicly in front of everybody else in the group, it's like they get these like decks of cards that has like suggestions of things. And that just makes it a little less like everyone is, you know, on them. So that was something that was helpful too.
Emma, did you have a question?
Yeah, I did. I had a question that was related to something that I think y'all both touched on, which was the recruitment aspect. You know, I, like you, Christina, I'm at a university where I only have undergraduates. And so that's, you know, that's the students that are doing research with me. But one thing that I'm curious about, and I'm still trying to fine tune for myself, is that recruitment aspect. And Eda, I know you said that you try to recruit at least one first-year student every year, right? And especially that early on, I guess, if you could give a little insight into the kinds of things you ask or the things that you look for, because, you know, on paper, a lot of our first-year students really look the same, right?
So yes, first year students are challenging because they are in the transition at the campus. They are in a sheer panic, getting all those schedules put together, and then, you know, professors are tougher than high school teachers. So, but it's challenging. However, the reason I'm recruiting in the first year, because creating a pipeline, so then the earlier they start, they can have more experience in research and then more productive, and then they can add more things in their CV. And so at University of Toledo, we have an undergraduate research council. And then they are providing stipend, summer research stipend, and they do also fall and spring, but summer is the most popular. Anyway, and that deadline is mid-February, so proposal deadline. And undergraduate students need to write a proposal, 10 pages or so proposals into that, you know, council, to pitch their research idea. And in that, all students, you know, the sophomore, junior, and senior students, they are evaluated in the same pot, but they separated first year student from the pot. And so, because, you know, you cannot expect the same thing from first year. So I ask so when I pick first year students, I'm teaching freshman design classes. So I can see that which student can really do better in the lab by looking at their, question and performance in the design class and everything. So I can say, I approach those students, have you ever considered research? Would you like to do research? Because, they don't know they can do research and then take classes. And then usually those students, I ask 5 of them, and usually 3 of them say, yes, I would love to do research. And then usually 1 or 2 of them write the proposal because I ask them to write the proposal because that's just showing me their commitment. And with this 1 or 2, usually freshman students are encouraged to do research, so they are given the stipend over the summer, around $3,000. Not that bad, I guess, for a first year student. So they start to working in the summer. And then what happened is usually University of Toledo is a co-op institute. So we have 3 mandatory co-op. So they can, not in their sophomore year, but they can take entire semester in research and then do research in that semester. And then they stay with me until senior year. So, but that's how I approach in freshman year, and then how I recruit them.
So I usually don't take first year students, but we do have, like during the academic year, I should say. So as I mentioned before, I take them in the summer. So we have a couple of programs that fund students. So I specifically am looking for students that are coming from underrepresented backgrounds or at-risk backgrounds. And so there is a program called the Rapidly Accelerated Research Experiences, or RARE. And so I take students through that program. And so that's been really helpful. Usually students are paired up by interest. So they're already pre-screened by the program as being high achievers anyway, who are interested in research. And, the data shows that students that are engaged in research do better academically overall. And so, I've really gotten heavily involved in that program. And so that's where the students usually come from. That said, students still, even though they're coming through the program, they still interview with my group. So when I'm not there, I should emphasize. So students will talk more freely when I'm not there. They'll talk more freely when they're talking to a fellow undergraduate student. And then that helps us evaluate like what, it was talking about, are they serious? Do they actually want to do it? Are they going to be committed? Because it takes our time and resources, and time is very, very valuable. And so I then meet, this again is a luxury of having graduate students. I meet with my graduate students and we talk about who's looking for what for their project, that sort of thing. But I think the same thing would hold for you, thinking about what are you looking for? And I would really encourage you to, stick to like 2 students or something at a time. Because I think it's better than having 1, because they can kind of start to work together. But we try to only take 2 students a year, 2 new students a year, because that's really helped us manage that. And then I would rather there be more senior people around that can help than to have, a flurry of undergraduate students all at one time, like brand new students in the lab at one time. So I made that mistake very early on, and I was very overwhelmed. And so then I vowed to never do that again. And so now I know that was not the right, because then they don't know what to do, right? Or they rely on somebody else to do it and that sort of thing. So that has been really helpful. But in terms of recruiting, it gets easier. Like what Ada said before, like talk about it in your classes. A lot of times students just aren't aware. So I have a PhD student, he just won an NSF fellowship. He's a veteran. He had no idea what grad school meant. He's a first gen, none of this. And he took my class, and he's a senior taking my class, and he's a junior at the time. And he was just like, oh, you can just go into a lab as an undergraduate student. I was like, yeah, come on in. And then he just thrived. I mean, it was him realizing that that's what he wanted to do. He just didn't know that that's what he wanted to do. And so that's been really awesome to see that.
That's so cool. Yeah, the first year thing is like, I usually take juniors. And so I only have like one summer with them. And then usually they tend to stay on through the school year. But then I have to retrain everybody again. So it's an interesting idea to bring on somebody like maybe between the summer, their first and second year. Does anybody else have any questions from the audience? I had
Question.
Oh yeah.
Hi. So my question is, you're in biomedical engineering. And so I'm wondering if you notice any differences in training students in engineering versus the sciences, especially at the undergraduate levels. I teach high school students who do research. And so I'm just wondering if you've noticed any distinct differences on how you train engineers, because biomedical engineering can be like a hybrid type of environment.
I know my question.
I think so I do sometimes recruit undergraduate students from biology department as well. Since we do lots of cell culturing, and they are familiar with. But I never recruit if I'm recruiting undergrad from biology department, I never do freshman year because I cannot sense, how they can do. Usually junior or senior year students I recruit biology. I follow the same approach, and I don't do something different in engineering students than biology, and I also accommodate high school students as well. And same thing, I never say, okay, you are biology, basic science, you are high school, pre-college, or engineering. I think science is science. What they are doing is it's like getting a driving license. It doesn't matter what kind of model car you are driving, as long as you understand how to design an experiment, how to learn, evaluating the data. So we are teaching those kind of things. It happened to be in engineering, we are using some tools and this and that, but ultimately I think in the mentorship, my goal is to teach them how to do science, and it doesn't matter if it is biology or engineering students for me.
So can I ask a question? When you're having them write proposals, do you notice differences, like in terms of the outcomes, like the goals of the project?
The goal of the project, I decide with them. They cannot decide the goal of the project because especially in early years, they don't have that much sense.
Mm-hmm.
However, even for junior years, I don't want them to go something and do outside of the scope of my lab. So everything needs to be part of the big puzzle. Because then it's getting harder for me to tie up with grad students or with other results. So therefore, within the big picture of my lab, I decide the area that they can write. However, I didn't emphasize you need to do this, do that. I only give the big picture. Look, we are trying to do this in this project. So how would you like to solve this problem? And then they get an idea and write. But I, especially for freshman year students, I heavily involve in the editing of their proposals because obviously, they don't have experience. But junior year student, especially if they are already in my lab, they know how to write things, the objective hypothesis, those kind of things. Outcome is same, they just need to understand how to design experiment and create objective of their study, and then, you know, writing the hypothesis. So I don't see any differences between biology or bioengineering student. No.
I think when I have run into issues is with students, when students aren't necessarily doing an experiment, but they're building something or designing a prototype. And then they have a little bit more trouble trying to figure out, okay, I'm testing something, but I'm not necessarily, I don't have a clear hypothesis.
Yes. That's true maybe for, I think when they come from high school, especially for freshman year, they are all same. They don't know anything about anything. So they don't have any prior experience much. But I can, you know, I did have some students from basic science, physics and biology department. They did very well as much as engineering student, because we are not using heavily engineering formula or anything that they can scare, you know, just like we are easing them into, you know, look, this is the mechanical loading device we built. This is working, this and that. I'm not asking to write the code or anything. So they are not getting into the hardcore engineering part of it, but it's just a tool for them. As long as you teach them how to use it, they feel comfortable. Yeah.
Thank you.
Sure.
I can add that I had the same experience. I've had biological sciences, physicists, and chemists in my group, and there was no difference. They maybe are less interested in some of the coding, but that doesn't mean they don't have to do a little bit of it if their project requires. So I haven't seen any differences between the students. I mean, I had a behavioral neuroscience student in my group. She was interested because she wanted to go to med school, and she's actually starting med school this fall, but she went to the NIH for a postdoc first. So all works out.
All right, well, I think we're just about out of time. Luke, did you want to, I know you're recording this. Is there somewhere where we can access it later, or?
So an email will go out to all of the attendees today and all of the folks who RSVP'd with a link to this. And it's very likely we'll also share that out in the CUR community. So you can look for it there as well.
Well, I just want to thank you all for setting this up so that we could celebrate our engineering undergraduate research mentoring award winners. It's been awesome to hear all of your experiences, and I definitely wrote down a lot of different ideas from your presentation. So I just want to thank you so much.
Thank you for organizing it. Thank you so much.
Bye. Thank you.
All right. Thank you all so
Bye.
much. Have a great afternoon.
Bye.
Thank
Take
you.
care. Bye.